Hi everyone, let us discuss this example. So in this example, y is equal to x cube e raised to x. Okay, so this function we have and we have to prove that it satisfies these two equations. The first one is y3 minus 3y2 and so on. Okay, so the third derivative is involved here and here nth derivative is involved. So now our focus is on this first equation. We will prove that y satisfies this equation and then we will go for the second one. Okay. Let me write what we have. We have y is equal to x cube e raised to x. Now what will I do? I will take its derivative. Okay. So derivative of y is y1, or you can write dy by dx also, but it is better to write y1. Okay. Since we have to go up to third derivative and after that we have to go up to nth derivative. So y1 means derivative of y. See, if you take its derivative, there is a product of two functions, so that's why I should use u into v formula. First into derivative of second plus second into derivative of first. X cube as it is, derivative of e raised to x plus e raised to x as it is, derivative of x cube is 3x square. Simply I use u into v formula, right? If you don't know, let me write it here. See, derivative of uv is equal to u derivative of v plus v derivative of u. This is u into v formula. So when you have a product of two functions, we have to use this formula to find derivative. Okay. So therefore, what will we have? y1 is equal to, this is nothing but y, right? Y plus 3x square e raised to x. Okay, I will call it as equation number 1. See the first, this is y, no, this is y. So the first derivative we have got. We have to go up to third derivative. Let us take one more derivative. Let me simply mention differentiating with respect to x. Derivative of y1 is y2. Addition is there. You can take separate derivatives. Derivative of y is y1, right? Plus 3 is a constant. Keep it outside. There is a product of two functions. So that means again I have to use this u into v formula to find derivative. Let us apply that formula. X square as it is, we write first function as it is, derivative of e raised to x, e raised to x. Now e raised to x as it is and derivative of x square is 2x. Let us solve this bracket. So this is y1 plus 3x square e raised to x, 3 into 2 6 x e raised to x. Okay, there is no more space to write. Let us continue it here. Just a minute. Okay, so y2 is equal to y1 3x square e raised to x. We have seen it somewhere here, 3x square e raised to x. Will you tell me what will be its value from equation 1? If you shift y on this side, you will have y1 minus y is equal to 3x square e raised to x. So this value I can put there, getting here. So value of this term 3x square e raised to x, y1 minus y. So let me write y1 minus y and plus 6 x e raised to x. So that means y2 is equal to 2y1 minus y plus 6x e raised to x, equation number 2, right? So we have got second derivative. We have to go up to third derivative. That means one more time we have to differentiate. So differentiating with respect to x, derivative of y2 is y3. 2 is constant, derivative of y1 is y2. Getting? First derivative already we have, so if you take one more derivative, it will be y2 minus derivative of y is y1 plus 6 is constant, x e raised to x. That means again u into v formula, since there is a product of two functions. So using u into v formula, x as it is, derivative of e raised to x plus e raised to x as it is, derivative of x is 1. So that's why I will not write anything. So y3 is equal to 2y2 minus y1 plus, let me solve the bracket, 6x e raised to x plus 6 e raised to x. Okay, so let me remove this formula, so we'll have more space to write. Okay, so see now what will I do? Let me write it again. y3 is equal to 2y2 minus y1 6x e raised to x. We have seen it somewhere here, 6x e raised to x. Okay, so can you tell me what will be the value of 6x e raised to x used from equation 2? Simply these two terms you have to shift in left hand side, then you will have the value of 6x e raised to x. What will be its value? Y2 minus 2y1 plus y. If you shift these two terms on this side, you will have the value of 6x e raised to x. That value I am going to put it here. 6x e raised to x is y2 minus 2y1 plus y, and the last term is as it is 6 e raised to x. I should mention it here from equation number 2. Okay, and previously also we used equation number 1 somewhere here, right? So I should mention from 1, this was from 1, and this is from 2. That's it. Okay, now we have to simplify only. Y3 2y2 plus y2 3y2, y minus y1 minus 2y1, that means minus 3y1, and y we have only one y we have, plus 6 e raised to x. So now what will I do? I will keep 6 e raised to x in right hand side, and remaining terms we will shift in left hand side. So sign will get changed. Y3 minus 3y2 plus 3y1 minus y is equal to 6 e raised to x. I think same thing we have to prove, right? Yes, we got it. Same thing we want. Okay, so the first task is over. So we have to prove the second part now. So here nth derivative is involved. So let us take nth derivative. Taking nth derivative, right? Nth derivative. So y3 nth derivative. You know that when we take derivative, if addition subtraction is there, we take separate derivatives. If constants are there, we keep them outside. So here also I will do the same. Minus, I am taking separate nth derivative. 3 outside. 3 is a constant, no? Nth derivative. 3 is constant. Keep it outside. Nth derivative. Nth derivative of y. 6 is constant. Keep it outside. E raised to x. Nth derivative. So already third derivative we have taken, and again we are taking nth derivative. So the total derivatives are n plus 3. Okay, simply we add those numbers, n plus 3. Minus 3, what I should write here? Y, n plus 2. Already two derivatives we have taken, and again we are taking nth derivative. So addition is n plus 2 plus 3. Here I supposed to write yn plus 1 minus yn 6 e raised to x. You know that derivative of e raised to x, e raised to x. Second derivative e raised to x, third derivative. If you take any times derivative of e raised to x, you will have the same e raised to x. So that's why I am writing e raised to x. So I think in this way we proved the second part also, right? Yes, we got the second part. So in this way we completed the example. Okay, make a screenshot of it, then we will stop. Thank you. Bye bye.